Great. All right, so just like we did last time when we were talking about combining like terms, before we get going with the multiplying radicals, I'm just going to slide the page up, and I want you to remind me what happens if I have something like this. I have an x, and then a parentheses, and then a 3x plus 5. You distribute. Perfect. Great words. You guys are doing awesome. I love it. And so we distribute. And so we take the x times the 3x, and that gives me x squared, and then the x times the 5, and that gives me 5x. Okay, something you've been doing since the first algebra class you ever had way back whenever that was. Okay, well, now we're going to do that same thing just with radicals. Remember this thing. Talked about it last class. When you're multiplying radicals, you can multiply stuff outside by other stuff outside, and you multiply stuff under radicals by other stuff under. You don't cross over. So here we go. I got my first example, and I've got several exercises for you to do the same thing. So I've got the square root of 5 times 2 square root of 3 plus square root of 6. So here it goes. Square root of 5 times 2 square root of 3. What do you think I get when I multiply those two things? 2 square root of 15, perfection. Okay, there's no other thing outside the radical, so the 2, and then 5 times 3 is 15, great. And then square root of 5 times square root of 6 is perfect. This particular problem we're done, but I'm just going to make a little note for you. If you can, you simplify any radicals. Those two numbers, 15 does not have a perfect square factor, a factor from our list. 30 does not either. Okay, that's going to happen at some point on our sheet as we go through, so just be aware, keep your eyes on the lookout. Exercise 1, it's pretty much the exact same problem. Give it a try, please. All right, so let's distribute on this one. So I've got square root of 10 times 4 square root of 3. What do I get when I multiply those? Perfect. Sounds like you're doing pretty good on this. I'm happy. And then square root of 10 times negative square root of 7. Okay, great. And again, if you used your calculator just to verify, there's no perfect square factors of 30 or 70. So we're going to move on. Any questions so far? Exercise 2 then, right down below. Okay, so here we go. Check your work with my work. If you have any questions, please bring them up. Questions are awesome. So here we go. 2 square root of 3 times 5 square root of 2. Notice we have stuff outside the radical on both of them and stuff under the radical on both of them. So the 2 times the 5 gives me a 10. And then the square root of 3 square root of 2 is square root of 6. You with me on that first term? All right, and then 2 square root of 3 times negative 7 square root of 3. The 2 times the negative 7 is negative 14. Square root of 3 square root of 3 is square root of 9. Now, if you did that, you did fantastic, but I can simplify one of those radicals. Yep. What's the square root of 9? 3. So this is really saying 14 times 3, and 14 times 3 is 42, I believe. There we go. No radical on that second term. We took the square root Once you take a square root, the radical goes away. You performed the operation, and so it's just plain old 42 at that point. If you got a question about it, let me know. If not, exercise 3 right next door. Same process, same, very similar problem. Just 3 terms this time. So I'm trying to get started. Check your work with mine. You gotta ask any questions to follow up, please for sure do that. Okay, so here we go. 2 square root of 5 times 6 square root of 7. That's going to give me 12 outside the radical, and then square root of 35 under the radical. And then minus 2 square root of 5 times 2 square root of 3. The 2 times the 2 gives me 4. Square root of 5 square root of 3 is square root of 15. And then last but not least, 2 square root of 5 times 4 square root of 10. 2 times 4 is 8. And then square root of 5 square root of 10 is square root of 50. Am I done with the problem? No. Which radical do I have to look at? Yeah, 8 square root of 50. In fact, on our warm-up problem on the board, you can see, but just real quick, in case you didn't see that, I'm just going to off to the side on the scratch work to save myself. Well, I can just do it right here. It's fine. 35 and 15, those do not have perfect square factors, but 50 does. 50 is 25 times 2. And then let me rewrite this one more time. Square root of 25 is 5, and so that means I have 8 times 5 or 40 outside the radical, square root of 2. None of those are like terms, so I can't do anything else. We're done. Okay, one more straight distributing problem, then we're going to move on to the other situation of multiplying. So exercise 4 right down below. If you need anything from me, raise your hand. I'll come to you. We'll talk about it. All right, so let's distribute here. So we've got 6 square root of x times 3 square root of y. So 6 times 3 is 18. The square root of x, square root of y is the square root of xy, just all under one radical. And then plus 6 square root of x times the square root of x is going to give me 6. Square root of x times square root of x is the square root of x squared. And pretty clearly, I can simplify that second radical. And so when I take the square root of x squared, I have 6 times what? Perfect. Great job. Awesome. All right, so that's what you do if you have a monomial out there. It's just distributing stuff you've done before. It's not a new skill. You're just doing it now with radicals. And the same thing's true for my next example, example 2 here. It's not a new skill in any way. You're just doing it with radicals. If I have 2 binomials, 2 things with 2 terms, square root of 5 plus 3, square root of 6 plus 1. Does anyone remember the acronym that I use to remember to multiply all the parts together? FOIL. Yep, 2 binomials. FOIL. So all you're going to do here, first, remember the acronym, FOIL is first, outers, inners, lasts. Okay, all it is a handy way to remember to multiply all the pairs. If you don't like foiling and you just want to do it a different way, that's great. Just you got to multiply all 4 pairs of things. So here we go. So my firsts, square root of 5 times the square root of 6, that is the square root of 30. Okay, that's not going to simplify. 30 is 6 times 5 or 3 times 10. There's no pair of factors that have a perfect square. My outers, square root of 5 times 1 is square root of 5. Always like to multiply by 1. My inners, 3 times the square root of 6 is 3 square root of 6. And then my lasts, 3 times 1 is just 3. And there we go. Nothing there simplifies. I am done. So it's just taking this multiplying radicals, foiling. If you got a question, ask it. If not, let's move forward to exercise 5. If you need me, raise your hand. I'll come to you. Go ahead and foil together those in exercise 5. All right, so I'm going to start foiling. You get something different than me and you don't understand why we're different, then let's talk about it. And so here goes first. My 7 times the square root of 5. The 7 is outside the radical, so that's just going to be 7 square root of 5. My outers, 7 times the square root of 2. Again, the 7 is outside the radical, so that's just 7 square root of 2. My inners, the negative square root of 3 times the square root of 5. Well, those are both under the radicals, so that's negative square root of 15. And last but not least, negative square root of 3 times square root of 2. Again, both under the radicals, negative square root of 6. How are we doing? All right, then go to the next one, exercise 6. We're just going to practice this skill so that we can remember it. Hopefully, when the test comes around. All right, let's see how you did on this one. First outers, inners, lasts. So my firsts, 4 square root of 2 times 5. The 4 and the 5 are both outside the radical, so that is 20 square root of 2. Then my outers, 4 square root of 2 times negative square root of 6. So the 4 times the negative is negative 4. Square root of 2, square root of 6 is square root of 12. My inners, square root of 3 times 5 is 5 square root of 3. And then my last, square root of 3 times negative square root of 6 is negative square root of 18. Now, if you did that, you got those 4 terms. You're doing a fantastic job. But I can simplify some of those. Which ones can I simplify? Yep, and then, yep. So if you don't mind, I'm just going to simplify the radical right below just to save myself from having to write the whole line. But the square root of 12, what's the perfect square factor there? Yep, that's exactly right, 4 times 3. And then square root of 18, that was one of our warm-up exercises today. That's 9 times 2. So we're going to notice a couple things that happen, but we're just going to do this one thing at a time. Okay, we're not in a rush. Okay, this term, so I got 20 square root of 2. Nothing's happening there. I can't simplify the square root of 2. We just said square root of 12 was 4 times 3, so this square root of 4 is 2. 2 times the 4 that's already outside is negative 8 square root of 3. Now, I did a couple steps there. Are we okay with that? Then I've got plus 5 square root of 3. And then minus, and then the square root of 18, we said 18 was 9 times 2. The square root of 9 is 3, so that just becomes 3 square root of 2. Again, if you did that, or if you were doing that when I started the problem, you're doing awesome, great job. And then there's one more thing we noticed once we're done, we ended up with some like terms. So I've got 20 square root of 2 minus 3 square root of 2, that is 17. And then I've got negative 8 square root of 3 plus 5 square root of 3, that's negative 3 square root of 3. So exercise 6 kind of contains all of the skills we've been talking about for the last 2 days. Simplifying radicals, the product rule of radicals, multiplying radical things together. It's all in there. So that's a pretty comprehensive problem right there. I don't want to move on too quick. Anybody got a question about any of those steps? All right, exercise 7 then. Go for it. Got some similar parts. All right, so again, I'm just going to get started. Don't let me rush you. Feel free to ask whatever questions you need to about this. So square root of 2 times 4, that 4 is outside the radical, so it's just 4 square root of 2. The outers, square root of 2 times negative 3 square root of 2, that is negative 3 square root of 4. Then my inners, square root of 5 times 4 is 4 square root of 5. And then my last, the square root of 5 times negative 3 square root of 2 is negative 3 square root of 10. Multiply stuff outside by other stuff outside. You multiply the stuff under the radical by other stuff under the radical. And I've got one thing that I can simplify here. This square root of 4 becomes 2. So that's negative 3 times 2 or negative 6. No more radical. And then the rest of it, I'm just going to write down. Boom, done. Get started at exercise 8. If you have a question, raise your hand. I'll come to you. I'm happy to answer. I'm happy to look at your work, see if there's something that you're not clicking. All right, so I'm going to begin my foiling journey here, and then we'll have a little simplifying. Then I've got a couple of things to say about this particular problem. There's a reason why I've given it. So here you go. My first, the square root of 6, square root of 6, that's the square root of 36. My outers, the square root of 6 times negative square root of 2, that's negative square root of 12. My inners, square root of 2 times 6, that's positive square root of 12. Notice these signs are different. They're opposite signs. So these middle terms have opposite signs. And then my last, square root of 2 times negative square root of 2 is negative square root of 4. I can do two things here simultaneously. My firsts and my lasts, they are perfect squares. So I'm going to simplify those. I notice my outers and inners, I can simplify those, but I'm not going to bother because they're like terms and they're just going to cancel. One's a positive, one's a negative. So negative square root of 12, positive square root of 12, I'm just going to go ahead and cancel those right now. They're like terms. I don't need to go through the effort of simplifying those. If you did, they're both just 2 square root of 3. So positive and negative 2 square root of 3, they're still going to cancel. And then the square root of 36 is 6. Negative square root of 4 is minus 2, and 6 minus 2 turns out to be 4. So the reason I gave this problem before we turn the page is it's interesting mathematically that I start out with these two binomials that have radicals, and I end up with a whole number answer. This is going to be a tool for us for this section when we turn the page, and also when we come back on Monday for the section we have. These two things, when you have the same two things, the only thing that is different is the sign in the middle. What you have, math people like to have a word for everything. They're called conjugates. They're called conjugates. I'm not super concerned that you remember that word or not. Write it down because my math lab might use it when you're doing your homework. But I do want you to remember how we're going to use it when we turn the page. It's going to be a useful thing for us in the process of dividing radicals. Okay, we've got one more multiplication problem we're going to do. So we're going to flip the page. because I just want to make sure that you see everything that you're going to see when you're on your own, so they're in your notes that you can refer to. I have 8 plus the square root of 5 squared. I just want to remind you what to do with a binomial when you have an exponent. Because our tendency, what we really want to do, because it would be nice and easy if it worked, would just be to say, oh, 8 squared is 64, and square root of 5 squared is going to be 5, and then you're done with the problem. But you can't do that. Here's what you have to remember when you see the squared, is that means whatever's in the parentheses, I multiply by itself. So you got to do this. 8 plus the square root of 5 times 8 plus the square root of 5. And then you're going to have to FOIL that together. So I'm going to give you 30, 45 seconds to FOIL, make as much progress as you can on squaring that binomial. Okay, so my first outers, inners, last. My first 8 times 8 is 64. And then my outers, 8 times the square root of 5 is 8 square root of 5. Notice because I'm squaring, these things have the same sign. So my outers and inners are not going to cancel like they did on the last problem. So I have another plus 8 square root of 5. And then I have finally the square root of 25. And when we go through this, square root of 25 is 5. So 64 plus 5 is 69. And then 8 square root of 5, 8 square root of 5 is 16 square root of 5. And there is my final result. That's all my multiplying problems I have. Before we move on, anybody got a question, comment, or concern about multiplying? Okay, well, you got the weekend to practice, get good at it, be great. All right, so dividing. Here's the interesting thing about dividing radicals. There's actually no dividing involved. Okay, dividing is we're just going to kind of use our multiplication ability. What we call it when we divide radicals is called rationalizing. The denominator. And I know the word rationalizing is a nice fancy word. All that means is I want my denominator to not have a radical. So if you don't like the word rationalizing, make a little note to yourself that the goal here is we want the denominator to not have a radical. That's really the goal of dividing your radicals. It's really the best you can do, is I want the denominator to not have a radical. So how do I do that? Well, great question. So here we go. The first of 4 problems, I've got 1, then you're going to have 3, is what happens when I've just got a single thing in the bottom, a monomial. So here's what I'm going to do in example 3. First thing I'm going to do is I'm going to apply the quotient rule of radicals. I'm going to give the numerator and denominator their own. I'm going to split it apart. So I've got the square root of 49 in the top, and I've got the square root of 6 in the bottom. Now on this one, before I worry about the rationalizing the denominator, we haven't done that just yet. I am going to simplify this a little bit. The square root of 49 is 7. Now I'm ready. I'm going to rationalize the denominator. I have a square root of 6 in the denominator. for math reasons that we don't need to get into, math people do not like irrational numbers or square roots in the denominator. So that what we're going to do is we're going to find a way to rewrite this without a square root in the bottom. And the process when there's a monomial is nice and straightforward. All you're going to do is multiply by the square root of the same thing. And here's why that is. So when you do that, in the top, you've got 7 times the square root of 6. No big deal there. In the bottom, you have square root of 6 times square root of 6. You've multiplied by the same thing. So now that becomes the square root of 36. And the square root of 36 is 6. No more radical in the denominator. Now I'm going to address something I addressed on Monday, because I know somebody in here wants to do this. Can I cancel the 6s? Why can I not cancel the 6s? One's under the radical, one's not. Well said. Okay, so resist the desire. I know it's there. Okay, that is done. 7 square root of 6 divided by 6. So exercise 10 is essentially the same problem. Rationalize the denominator of that problem, please. Just to give everybody a nudge, what are we multiplying the top and the bottom of this one by? Square root of 7. Well said. Keep going. So in the top, I've got a 3 outside the radical and then square root of 7. So the top is just going to be 3 square root of 7. In the denominator, square root of 7 times square root of 7 is the square root of 49. And as will happen every time we do this process, the square root of 49 is 7. There we go. No more radical in the denominator, which is my only goal when I'm asked to divide. If you got a question, ask it. If not, exercise 11. Again, it's going to work very similarly. Again, just to give everybody a nudge, what are we multiplying the top and the bottom by? Perfect. Well said. All right, so when I multiply in the numerator, I've got 9 square root of 5 times the square root of 3. That's going to be 9 square root of 15. 15 is not going to simplify at all. It's 5 times 3, so there we go. In the denominator, square root of 3 times square root of 3 is square root of 9. Again, I can't cancel the 9s because one's under the radical and one's not. Okay, so I'm going to go ahead and simplify. So I've got 9 square root of 15 over square root of 9 is 3. Can I reduce anything this time? What can I reduce? Why can I reduce the 9 and the 3, both of those? They're both real numbers. They're both outside the radical. Yes, excellent work. And so 3 goes into 3 once, 3 goes into 9 3 times, and that leaves me 3 square root of 15. All right, one more of these. Exercise 12, I just wanted to give you one with a variable. The process does not vary at all. The exact same thing. So we're going to multiply the top and the bottom of this one by what? Not just, I know you mean the right thing, but say it for me. Not just x, but square root of x. Yes, I know you mean it. I know you probably wrote it down. Just want to make sure we're saying the right thing. That's all. So in the top, square root of 6, square root of x, that's the square root of 6x. Great, nothing else to do there. The denominator, square root of x, square root of x is square root of x squared. And so then one more step, I can simplify that denominator. Square root of x squared is x. Again, no more radical in the denominator, which is the goal. All right, we're almost done. Okay, if you got any questions, please ask them before we get to the finish line. Here's how we're going to end our day. I need to do the same process in example 4, but this time notice I've got 2 terms. Well, this is where, you don't have to flip the page, but I am. This is where, just to remind us, this is where this process comes in. I'm going to remember that, hey, if I multiply by a conjugate, I'm going to end up with something with no radicals. Okay, so what we're going to do, when you've got a binomial like example 4, and you want to rationalize the denominator, you want to get rid of the radicals, what you're going to multiply by is the conjugate, 5 minus the square root of 7. The conjugate is just you flip that sign. Whatever's in between them, you use the opposite sign. So this one was a plus, so I use a minus. Your problem you're going to do in a minute is a minus, so your conjugate's going to be a plus. So we do that in the top and the bottom. So here goes. In the numerator, 4 times 5 is 20. 4 times the square root of 7 is 4 square root of 7. In the denominator, I FOIL. That's why we practiced foiling a little while ago. So this is the exact same skill. First, 5 times 5 is 25. Outers, 5 times negative square root of 7 is negative 5 square root of 7. Inners, square root of 7 times 5 is plus 5 square root of 7. Oh, we see those are going to cancel. That's great. And then square root of 7 times negative square root of 7 is negative square root of 49. Once again, the top stays the way it is. It is 20 minus 4 square root of 7. In the denominator, the negative 5 square root of 7, the plus 5 square root of 7, those are going to cancel. And I have 25 minus the square root of 49. That's 25 minus what? 7, so that's 18. Now, this last bit won't happen with all the problems, but it happens on my example. If you can reduce, you can reduce. Just remember that division is distributive just like multiplication. So you can only reduce if you have the same factor in all the terms, which I do. What is the factor that's in common to 18 and 20 and 4? How can I reduce that? By a factor of 2. Yes, 2 goes into 20 and leaves 10. 2 goes into 4 and leaves 2 square root of 7. And 2 goes into 18 and leaves 9. Okay. That doesn't happen on all of them, but I wanted it to happen on my problem just to let you know. Okay, exercise 13. Go ahead, real quick, just write down what the conjugate is, and then once we confirm that, I'll give you some time to do the rest of the problem. And what'd you write down as the conjugate? Excellent job. Go ahead and finish it then. Great job. All right, so you told me the conjugate was 4 plus the square root of 3. That's great. So up top, I have 5 times 4 is 20. And then 5 times the square root of 3 is 5 square root of 3. In the denominator, my firsts, 4 times 4 is 16. My outers, 4 times square root of 3 is 4 square root of 3. Inners, negative square root of 3 times 4 is negative 4 square root of 3. And then lastly, negative square root of 3 times the square root of 3 is negative square root of 9. So once again, the 4 square root of 3 minus the 4 square root of 3, those things cancel. So my top is 20 plus 5 square root of 3. My bottom is 16 minus the square root of 9. So what does the denominator become? 16 minus 3 or 13, just like you said. Perfect. Great job. All right, 2 more problems. We just got to do this process 2 more times. Exercise 14. The reason I'm giving you this one is just because the top is also a binomial. So you're just going to have to FOIL the top. Okay, it doesn't really change anything about the process. Okay, so my conjugate, I think you all have written down square root of 5 plus the square root of 2. Just got to change that sign in the middle. And then I've got foiling to do. I've got foiling in the top and in the bottom. So in the top, my first square root of 3 square root of 5 is square root of 15. My outers, square root of 3 square root of 2 is square root of 6. My inners, square root of 7 square root of 5 is square root of 35. And then finally, lasts, square root of 7 square root of 2, square root of 14. If you don't have these 4 terms in that order, that's fine, as long as you have all 4 of them. Okay, so if you didn't FOIL, if you did like FEOL or flowy or something like that, or if you have a completely different method, as long as you have these 4 terms in whatever order, you're good to go. In the denominator, again, square root of 5, square root of 5 is square root of 25. My outers give me square root of 10. My inners give me negative square root of 10. And my lasts are negative square root of 4. So it'll take me a moment to rewrite the top. So there's just 4 terms here. So square root of 15, square root of 6, square root of 35, square root of 14. The bottom of this is going to simplify nice. The square root of 10 minus the square root of 10, those cancel. Square root of 25 is 5. Square root of 4 is 2. So 5 minus 2 is 3. If you got any questions, if you need any help with this last one, let me know. One more. I just gave one with some variables, just so that, again, so you've seen everything that you possibly can see. All right, so on this last problem, the conjugate is just going to be square root of x plus the square root of y. Always just change that sign in the middle. The conjugate is no more complicated than that. And so in the numerator, I've got an 8 times that, so that's 8 square root of x plus 8 square root of y, a little distributing. The denominator, I'm going to go ahead and FOIL those two binomials. So the first square root of x is square root of x squared. My outers, square root of x times square root of y is plus square root of xy. The inners, negative square root of y times x is negative square root of xy. And then finally, negative square root of y times square root of y is negative square root of y squared. The top, nothing changes with the top. It's not super interesting. In the denominator, square root of x squared is x. The outers and inners cancel. And minus square root of y squared is minus y. And that's it.